Hello, my name is Shadi Mohamed-Amine. I am a PhD student at the University of Qadi, Marrakesh, Morocco, and today I will be presenting our work entitled Inverse Reinforcement Learning for Healthcare Applications, a survey by me and Professor Hajar Musannif. At the second International Conference on Big Data, Modeling and Machine Learning in the University of Ibn Tufail. So context. Reinforcement learning is a subclass of machine learning that deals mainly with learning optimal sequential decision making in a particular environment. And reinforcement learning has been very successful in various domains such as video games and robotics. And the question is, why not exploit the advancement in reinforcement learning techniques for healthcare applications? But to ensure good performance of reinforcement learning applications, an explicit reward function should be provided beforehand, which in most healthcare scenarios is either not trivial, unavailable, or too expensive to obtain. In fact, even doctors might disagree on what to value the most during the treatment of a particular disease. And this is where inverse reinforcement learning comes in handy. So IRL is the problem of inferring the reward function of an agent given its policy or observed behavior. The hope is that given optimal policies, such as a successful treatment regime of expert doctors, for example, we shall obtain the reward function. That is, for example, important factors that doctors were considering during the treatment. And although this is a survey, but there is quite limited work with respect to inverse reinforcement learning applications in healthcare. But here is a selected couple of state-of-art applications. First, we have diabetes treatment by Asso and collaborators, clinical motion analysis, ventilator weaning, and sepsis treatment. So this quite limited state-of-the-art applications of inverse reinforcement learning in healthcare can be referred to many reasons. Among these reasons are the challenges presented in this slide. So first category of challenges are regarding data in healthcare setting. Patients may fail to complete the treatment regime, yielding some missing data. And devices in clinical settings can be changed, and each device is subject to many inherent biases, resulting in a noisy and biased data. Also, for some complex diseases, clinicians still face inconsistent guides in selecting exact data as the state in a given case. The second category of challenges is using inverse reinforcement learning algorithm for a reinforcement learning application. And the reinforcement learning involves learning using trial and error, which implicates running the policy directly on the target population, that is the patient, which is just unethical. And the third category of challenges is known as the black box problem, which is the need for interpretability and explainability of these black box models, the reinforcement learning or inverse reinforcement learning models. That is, why the model performed the way it performed and what features matter the most, etc. Non-explainable algorithms will face strong resistance from clinicians as they aren't expected to try any new treatments without rigorous validation for safety, correctness, and robustness. But the aim of this survey wasn't to just review state-of-the-art applications of inverse reinforcement learning in healthcare, but also suggest some future directions for other researchers. And the first category of future directions is regarding handling missing data. either by using generative adversarial networks, meta-learning, or even knowledge transfer. The second category is modeling complex clinical settings by introducing the heterogeneity of doctors and patients using hierarchical modeling. Also, by extending the MDP to POMDP, which is partially observable Markov decision process, or even by learning the dynamics of the model too, using some algorithms such as word model. The third category is regarding inverse reinforcement learning for just important factor discovery, and this is by extracting the reward function of different expert doctors for a same treated disease using inverse reinforcement learning. We can use this knowledge to recommend decisions for other doctors that might help achieve the valued factors. And thank you for your attention.